Welcome to Arithmetic Progressions. We shall now discuss the nth term of an arithmetic progression. Consider the general form of an arithmetic progression a plus d, a plus 2d, so on, where a is the first term and d is the common difference of the progression. We shall start using a symbol called t. T for term number, 1 is the subscript that denotes the first term. So T1 means first term. The first term of this progression is A. The second term, you can see it is A plus D. The third term is A plus 2D. Let us see how we are getting the second term. The second term is got by adding one common difference with the first term. The third term is got by adding two common differences. This way, the fourth term is something what we should be getting by adding three common differences. So proceeding this way, we could see that if you have to get the nth term of this arithmetic progression, we should be adding n minus 1 common differences. For second term, one common difference. For 2 it is 1. For third term it is two common differences. That is, for 3 you have 2. So for n it should be n minus 1. So the nth term of an arithmetic progression is given by a formula a plus n minus 1 into d. It's a very important formula, students. If there are k number of terms, if there are exactly k number of terms in an arithmetic progression, then tk will be given by a plus k minus 1 into d. If there are exactly k terms, that kth term will be the last term of the arithmetic progression. The kth term will be the last term of the arithmetic progression. We have the practice of writing L for the last term, so please make a note of it. The last term of an AP, of this AP, is denoted by L. So this gives us an idea of nth term of an arithmetic progression, a plus n minus 1 into d. Students, we shall take a numerical example wherein we will be identifying the nth term of an arithmetic progression. Shall we go ahead, students? Yes. Find the 15th term of an AP, 2, 5, 8, 11. I repeat the question. Find the 15th term of the following AP, 2, 5, 8, 11, so on. Yes, clearly we could see one thing. The first term is 2. Second term is 5. So what is the difference between first term and second term? 3. Next, what is the difference between the third term and the second term? 8 minus 5 is 3. Likewise, this difference between 11 and 8, that the fourth term and the third term, is also 3. So you could clearly see that it's an arithmetic progression with the common difference as 3. And what are we asked to find? The 15th term is what we are asked to find. So we can comprehend what we wrote here, what we understood here. A is 2, D is 3, N is 15, since we are going to find the 15th term. What is the formula for nth term? A plus n minus 1 into d. Here A is 2, D is 3, N is 15. So what should we do, students? 2 plus 15 minus 1 into 3. 2 plus 15 minus 1 into 3. 15 minus 1 is 14. 14 3 is 42. 42 plus 2 will give us 44. So the 15th term of the arithmetic progression is 44. The 15th term of the arithmetic progression is 44. Let's now see where exactly we can apply this formula in a real life scenario. Prakash started gardening as a hobby by planting some flowering plants in his backyard. He started with 5 plants and decided to increase 2 plants every month. Find the number of plants in his backyard at the end of an year. At the end of an year, how many plants would be there? Let's try reading it, keeping arithmetic progression in mind. So the first sentence is what he is going to do. He is going to plant some plants. He is going to plant some flowering plants. Okay. First part is he started with 5 plants. That throws a clear hint that A equal to 5. And decided to increase 2 plants every month. So plus 2, adding 2 is what is happening. So the common difference is going to be 2. The first term is 5, common difference is 2, and the number of plants what he is going to have at the end of a year. As you all know that a year has exactly 12 months, which means T12, that is what we have to find. So n equal to 12 is something what we need to look at. So A equal to 5, D equal to 2, n equal to 12. I shall give you some time. Can you find out the 12th term? Yes. What would you do? A plus n minus 1 into D. That is 5 plus 12 minus 1 into 2. 5 plus 12 minus 1 into 2. 12 minus 1 is 11. 11 2 is 22. 22 plus 5 will give us what? 27. So, the number of plants at the end of a year is 27. Clearly, we could apply the nth term formula so as to get the number of plants at the backyard at the end of a year. In his backyard at the end of a year is something what we could get as 27. Thank you, students.